Ever wished your AI assistant could actually remember what you talked about last week? Or, a big idea you had months ago? It's one of the biggest hurdles in AI today, but a brand new approach might have just cracked the code. So let's dive into this quest to build an AI with a perfect memory.
This quote from way back in 1787 is amazingly at the very heart of our story today. Researchers are figuring out that for an AI to truly remember, it has to learn how to pay attention in a completely new way. It's not just about storing stuff, it's about knowing what's important enough to keep in the first place. To really get a handle on the problem, it helps to think about our own minds, right? We've got our short-term memory, which is juggling everything that's happening right now. And then we have our long-term memory, which is like this vast archive of everything we've ever learned. The dream is to build an AI that can do both of those seamlessly.
So what's the big holdup? Well, for all their incredible power, today's AI models have this fundamental flaw, a kind of digital amnesia. They can be absolutely brilliant in the moment, but their connection to the past, it's surprisingly fragile.
See, the reason for this is something called a context window. The best way to think about it is like a spotlight. The AI can only see and process whatever's inside that beam of light. Anything outside of it, even something you said just a few moments ago, basically just vanishes. It's gone.
Okay, so let's dig a little deeper into the why. The architecture that runs almost everything right now is called the Transformer. It's the engine behind ChatGPT and all the big names, and it turns out its very design is what creates this memory bottleneck.
The Transformer's superpower is its attention mechanism. It's incredible. It can look at all the words in its context window at the same time and instantly figure out which ones are the most important for what it's trying to do. It's a master of understanding the now.
But that superpower, it comes with a very steep price. The more information you try to stuff into that context window, the harder the transformer has to work to keep track of it all. And it doesn't just get a little bit harder, it gets exponentially harder.
And this chart really just lays the problem bare. If you double the amount of information you want the AI to remember, you don't just double the work, you square it. This is what's known as quadratic scaling, and it basically means that an infinite memory is impossible with this design. You would literally run out of computing power on planet Earth.
But what if you could just start over, redesign the system from the ground up? Well, that's exactly where this new architecture from Google Research called Titans comes into the picture. It's built from day one to shatter this memory limit. The whole idea behind Titans is to mimic the human brain by splitting memory into three distinct parts. First, it keeps that powerful attention module for its short-term memory to handle what's happening right now. But then, it adds a brand new part for long-term memory to store the important stuff from the past. And finally, it has a persistent memory, which holds general knowledge, kind of like our own basic understanding of how the world works. It's how these three work together that changes the game.
Okay, so this is where it gets really clever. How does this new long-term memory decide what's actually worth keeping out of a potentially infinite fire hose of information? The answer is, well, it's surprisingly intuitive. It's all inspired by us.
It all comes down to what the researchers call the surprise principle. Think about it. You don't remember every single breakfast you've ever had, but you definitely remember that one time a bird flew into your kitchen. Titans work the same way. They prioritize and lock in memories of things that are surprising, things that violate their predictions about what should happen next. So the whole process is just this constant, elegant loop. The model sees something new, it measures how surprising that something is, and then it updates its memory with the most surprising bits. And, this is just as important, it has a mechanism to forget, to clear out old, less relevant stuff to make room. It doesn't just fill up with junk.
And this is the real game changer here. The memory isn't just set in stone during training. No, it's a living system that learns at test time, which basically means it's updating and refining its understanding of the world with every single new thing it sees, just like we do.
All right, so the theory sounds amazing, but does it actually work? Well, the researchers put Titans through a whole series of absolutely grueling tests designed to push any memory system to its breaking point.
First off, just look at the sheer scale. Titans can handle a context of over 2 million tokens. To give you some perspective, that is the equivalent of the entire Harry Potter series. Traditional models, they can't even dream of getting close to that. But a giant memory is useless if you can't find anything in it, right? So they use the famous needle in a haystack test. You take one tiny specific fact, the needle, and you bury it somewhere in that massive 2 million token document. The AI's job? Find it.
And Titans finds a needle, consistently. This proves its memory isn't just huge, it's useful. It can pull out specific details with incredible accuracy from this just vast ocean of information.
Now check out these numbers from an even harder reasoning test. The Titans model hits over 95% accuracy. That is a massive leap over some of the biggest, most famous models out there, models that are way, way larger. It just goes to show that a smarter architecture can totally beat brute force.
So, what does this all mean for the future of AI? A breakthrough like this isn't just a small step forward. It really points toward a fundamentally new kind of artificial intelligence. We're not just talking about reading longer books. This technology could lead to AI companions that actually remember your preferences, or researchers that can pull insights from thousands of scientific papers. It's a shift away from these one-off, forgetful interactions to building a continuous, evolving partnership with AI.
Which, of course, leaves us with one last massive question to think about. What does our world actually look like? And how do we even interact with technology when an AI never, ever forgets?